organizing this event and for hosting me today, being the teacher, if you used to call me that. So today, let me just share my screen. Okay. I'm not familiar with Zoom, so I'm trying to find my way around this. Just bear with me. Share, that's it. There you go. Can everybody see my screen now? Are we?
Yes, we can see your screen.
Okay. Okay, good morning, everyone. My name is Nabil. I am a director training with Jellyfish Google Cloud, GDG Cloud, and a new program that Google have having this innovative champion in security and networking as of last week. So today we're going to have a combination of an introduction to Google Cloud, but also give you a chance to learn hands-on. So we'll, and this is what study jams are about. So to start with, if you could go to this link here, let me share it maybe on the chat, because there's a couple of steps that we need to do for later on. We're not going to have any issues. So let me just go to, second, how does that thing work out? Can't see the chat window. Okay, chat, yeah, there you go. And also, this is the study jump code. I'm going to share it in there. So what I'd like you to do, let me just open an incognito window. An incognito window, and you just do that and bring it into maybe the. Are you able to see my incognito window on the screen?
Yes.
Yes, sir.
Okay, so if we go to that link, let me just get that.
Recording.
All right. So today's session, we're going to do the create and manage cloud resources. I'd like you to enroll into this one and then use that code. It's super important that we do these steps now, because later on what we're going to be doing, we're just going to go through the hands-on. So all the things that should be happening, access and things like that. Don't want you to be out of sync later on where your friends are doing the labs and you are still struggling with access. Submit that. And you're going to need to enroll into this quest with your email. Let me see, is that going to be working? Okay. I'm already enrolled in that one. Choose this. Okay. If you put number 1 in the chat window when you get to this stage, so I know everybody is on the same. Okay, let me see how many of us are on the. Okay, so we are 15 of us in the room. So 15. I need to see 15 ones in the room, in the chat. Okay, let me go back. Maybe if you haven't been following, I want you to open an incognito window, and I want you to go to this room in case that you missed that. Let me just put that in. That was the code, but we want to be on. Once you go there, I want you to select the create and manage cloud resources. Track. And then you enroll with the code that I've shared on the chat window. Anybody having any issues with this, with these steps? So I want you to enroll into the quest. It will take you to that page. Okay, once you are there, I want you to click on the first lab. These labs are actually, this is what we call quick labs. Quick labs is the Google Cloud labs environment. Really, really good practice sandbox. Very, very well documented. One of the reasons I like this platform because it's not simulation. It's actually Google. They give you a real environment, what we call a project with all the resources for you to practice. That's the first thing. And the second thing you will notice is the format of the lab. You will always have an overview, but what you're going to do about this particular task, some summary summary paragraphs about the topic in the cloud services that are going to be covered, and the documentation, the screenshots, the steps. It's like a really kind of very well organized, very well documented, and it keeps track of your progress as well. So as you go along, you will basically have this checkpoints where when you answer, you submit, you will get green, and usually what you get some scoring for the lab. And then when you finish the lab, you finish all the steps and things, you will be able to see. So what I want you to do, we'll come back to that in a lot more details later on. I just want you to start this lab and leave it running. So probably for me, it's already done a few times, so it's not going to allow me to do that. It's going to come back with some kind of message that I've exceeded my. Okay, I need to find out first. Okay, bicycles. This is the only thing annoying about quick labs is this check here. Did it allow me this time? So what I want you to do, leave that window as is, leave it running, because it has to be running. It has to be running over 5 minutes, because you enter the code, and that's the process that you're going to be getting some credit in order to do our labs later on. Okay, are we all good up to this point? I'm just going to switch back to my slides.
جزيل الشكر. حتى الآن لم نعتز بالله حسن كنت معنا.
Okay, let's switch off a little bit about the Ukraine situation for a bit, and do some kind of quick labs instead of Ukraine news. All right. Okay, one thing we're going to be doing across this, just to have a feel of the audience, kind of what is the little bit about background, little bit about your knowledge of the cloud. We're going to be using something called Slido. So what I would like you to do is to either on your phone or your laptop, go to slido.com, or you can scan this if you can from the screen, and you enter this code studyjam-shj GDG, and you will be presented with this question. It'll just be interesting to see what is the a little bit of experience or knowledge of cloud in general, of any of those cloud platforms. So slido.com, and the code is in, it's completely you can see there's no right or wrong about this question, just to find out a little bit here about. Okay, Oracle Cloud, interesting. Not at all. This is the usual breakdown we usually see. There is no hiding. Obviously, there is no names that are going to be. I'll be able to see who answered, who hasn't, but I can see the number here. I've got 6 in here, but we are okay. We 20-ish in the room. So again, slido.com. You'll be presented with a code. Just tell us, what is your experience with cloud. Even if it's nothing at all, it's there. That's the aim of these sessions that we are doing here. Okay, I'm going to give it about another 30, 40 seconds. Slido.com. By the way, you don't have to do in capital, lowercase. You can put all that code lowercase if you wanted to, just to make things easier. Yeah, absolutely. We'll try to get you to that stage. All right, so 9 answered the questions. Thank you so much, those guys who gave us that feedback. Usually we'll get, I don't know, I've never done this study jam with only students, okay, but usually I see a 50%, 50% split. 50% nobody has any idea what cloud is, never touched it. And the other 50%, they would have some kind of experience with either of those other cloud providers, which is, I can see here that I've got a few more, which is pretty much the same or near enough. I can see 42% in the audience. They've got no idea of the cloud at all. And I've got other ones that got some experience with AWS. I can see a little bit of Google Cloud experience, which is good. All right. Okay. Thank you so much. That's super useful. Just give it a little bit of context here, just to as we go along. So we'll touch from the ground up really about cloud and Google Cloud in particular. Okay. Another one that I want you to participate here. We want to some kind of collaboration here. What is your idea of cloud? So when you hear cloud in a simple sentence, if you can put it in the chat, what is cloud for you? We keep hearing this buzzword for many years now. Some people scares them off. Some people are excited about it. Some people they engage. They try to learn it. Some people they even not entertaining the idea of touching cloud for different ideas, misconceptions about security maybe, and things like that. Okay, online data storage, that's a good one. We hear that a lot, online data storage. This is what we hear a lot, users, end users. And it's true, it's very true that nowadays nobody's gonna be buying those external hard drives and saving that data, and people are going now to G Drive, iCloud, this kind of stuff. Online computing, storage services, yeah, absolutely, that's another one. Yeah, absolutely, online computing, and we're gonna see a lot of that today. Yes, cloud provider takes care of security. Okay, which gonna take us to the next point, because there are two different things here, the cloud itself, and the next question is going to be about cloud computing. So if I bring that answer here, kind of the official answer to that, but I think you are all distributed manner of online storage with a set of services. Absolutely, I couldn't have put it better than that. But you can see it's a metaphor of the network of data centers. So the service that basically somebody else is providing for me. All those resources are somewhere in the globe, and I have access to those resources. I don't have to provision anything. I don't have to buy anything up front. It's there for me. I'm just going to be tapping into a pool of resources that I can use whenever I want. And all those kind of resources are in data centers that are attached to networking. And as a user, I will have access to that. So this is kind of the metaphor of what cloud is. Now, if I put the next question, which is, what is cloud computing? Then it's going to be kind of a different things. I've already seen a couple of answers that relate to that. So what is cloud computing? Now I am in your territory probably, because this is what they teach you in university. What is cloud computing? What are the concepts and things like that? So what is cloud computing? So cloud is those resources, those data centers that are attached. Cloud computing itself, how does it relate to cloud? What is it? No, as such, they're pretty much related to each other. Cloud and cloud computing. There is kind of a very, very strong relationship between the two, but it's not the same thing. Cloud, we said, is the metaphor of those data center attached and things. So cloud computing, what are we doing with that, basically? So what is cloud computing? If I give you cloud, Yeah, this is one of the things, executing programs on the cloud. Yeah, that's a really, really good answer. So we're talking here about leveraging the cloud, executing programs on there. So that's a really good answer. Any more? Anybody else? Storing, accessing data, absolutely. So we're leveraging another capability of the cloud with bringing our data, storing it, accessing it, processing it. So you've got an idea just with those shared space. Yeah, so we're talking about data again here. I think those answers, those 2 or 3 answers, I think they give you a very, very kind of strong idea what we mean by cloud computing. I'll give you another 30 seconds, maybe try to get a couple more answers. But I can see the idea is there. So basically what we're doing with cloud computing is we're leveraging that technology, the processes that are needed to store, manage, access data that is transfers over the cloud. So virtual services, absolutely, Harith. Yeah, absolutely. So the cloud is those services, those data centers that we got a metaphor for that we access. And then we leverage that cloud computing is bringing in that, leveraging that technology, using those processes that we're going to need to use to process our data, to store it, manage it, get value from it, get analytics from it, get that predictive power from that, and the rest of it. So let me summarize that, what we talked about, probably much from a different angle. Let me just share this video with you. Just let me know if you can hear the sound, otherwise I need to change some settings. Can we hear it?
No.
Okay, 1 second. I just switch one thing here. Just gonna change a couple of settings. Audio. Okay, let's try that. Now?
What is the cloud?
Yeah.
It's data.
Yes.
It's
Okay.
scalable.
Okay.
It's elastic.
It's servers, databases, and hard drives.
But it's bound in physical data centers. We're going to unveil something that completely changes the way you think about cloud. You know public cloud, and you may know private cloud, and you might even know about hybrid clouds and marketing clouds and elastic clouds. But today, now, there's actual cloud.
Introducing Google Actual Cloud Platform.
This is the world's first cloud offering running on servers in the troposphere, inside actual clouds. It's faster, it's more scalable, it's more secure. And most importantly, it looks like a real cloud. We're also releasing an industry-first performance feature, Storm Boost.
Storm Boost draws on the power of Mother Nature to give your persistent disks a 50% IOPS boost during thunderstorms.
And you can predict storage performance right from the developer's console by monitoring our new weather dashboard.
Or you can just look out the window.
Google Actual Cloud Platform is the culmination of groundbreaking scientific research on super-cooled water droplets, technological breakthroughs in high-altitude, ultra-low pressure chip design, and operational efficiencies related to the way we run non-terrestrial data centers.
I sleep more soundly knowing that my data is 30,000 feet above the ground.
I just love that I can see it.
This is the first step in an exciting journey. People say the sky's the limit, but we think bigger.
Clouds are so pretty.
That's not just a cloud, honey. That's Google Actual Cloud Platform.
Okay.
What is
There you go. Look out the window. Tell me if there is any clouds in Sharjah today.
No clouds, unfortunately.
Okay, just bringing some fun to it really here. Okay, awesome. All right. Okay, so let's start a little bit of just to get into more about cloud computing, and we jump into Google Cloud, and then we'll start doing some hands-on with that. So cloud computing. So actually, we need to start with this just to put it into perspective. So let's look at what it means to use cloud. Obviously, cloud is very different than what we call the real data centers. We call them on-premises infrastructure environments. So we will look a little bit into that. What does it mean to have different service models in the cloud? We will have a little bit of an idea of this. What are some of the common terminologies that we hear? Things like elasticity, fault tolerance, and then what does it mean from business perspective to use the cloud? So we'll talk about a little bit about capital expenditure, operation expenditure, those kind of stuff. So when you look at what it means I know it says that cloud computing, but really those 5 attributes we're going to talk about here briefly are for public cloud. And by the way, we have different types of cloud. So we'll talk about public cloud, and I'll tell you about another couple of clouds that are available nowadays. So when we look at what makes the public cloud useful, there are 5 attributes, or we call them 5 pillars, that I think if you Google it, the National Institute of Standards in the US has said are characteristics of the public cloud. And I like them. I think they are very good, very useful. So we understand the benefits of public cloud. So the first thing a cloud needs to have is this concept of on-demand self-service. So you should be able to provision these computing capabilities as you need them without requiring somebody to interact with. So you don't need a service provider. You not to pick up a phone and talk to somebody at your service desk, or walking to the help desk and ask them for, let's say, a virtual machine or more storage, which we know probably you've gone through this at the university with the help desk. It probably takes a couple of days. They've got their own SLAs and things like that. So this is kind of a big difference in here. When you're in the cloud, you should be able to have an on-demand self-service in order to provision those resources. And then you have a cloud service should be available through a broad network access using standard mechanism, web standards really. So this again says that you should be able to access these using this self-service mechanism, and you should be able to using a simple interactive front end like a web console, which we're going to be seeing in Google Cloud. Any cloud provider, they give you a web console to access. You've got your username, password, and basically you are in. You'll be able to provision those resources in the cloud. And then we have this resource pooling concept. So in the cloud, public cloud environment, the resources need to be pooled. What it means is that resources are pooled to serve multiple customers. So this is why we call it public cloud. So using this mode called multi-tenants. So we'll look into that as we get into subsequent topics that we're going to be covering. So what you will have, different resources are basically dynamically assigned. They are reassigned according to your demand. So today you're probably using a virtual machine. Tomorrow you're not going to need it. You're going to be basically deleting that. Those resources are going to be part of a big pool. So a cloud provider like Google or Amazon or Microsoft, they've got these big data centers across the globe.
They buy millions of servers, exabyte of storage. Networking is a huge network across the globe. So these providers, they buy in bulk. So which means that the customer will benefit from economy of scale by buying in bulk, which means that Google, for example, will pass a huge discounts by buying in bulk to their customers. So if the customers need more resources, you can give them from that pool of resources that is shared in a secure way by multiple customers. So this is kind of what we call a multi-tenant environment where multi-customers, they be sharing the resource. As opposed to when we talk, for example, about private cloud, it's the same concept, but the pool of resources is just for one specific customer, one specific company. They will have the same concept of having a console to log in and things like that, but the resources are for their own use only. So that's private cloud. There's a third concept before I move into the fourth and the fifth point is there, what we call community cloud. Community cloud, you will find multiple companies from the same industry. They're probably having same requirements when it comes to the type of compute they're using, the security. Usually it's about security. So different industries, they've got different requirements from security. So they come together and they create a cloud data centers. They be shared between them. So that's a community cloud. So which sits between private. It's not fully public and it's not private. It's in between. So that's what community cloud is. And going back to our 5 pillars or 5 features of public cloud, the fourth one is rapid elasticity, which actually ties closely with the pooling concept. So capabilities in the cloud can be elastically provisioned and released in cases that I don't need those resources. So automatically to scale rapidly, either outward or inward. If I need more resources, I'm just going to tap into that pool of resources very, very quickly, go get those. If my demand goes back down, I can put both resources back in, which basically takes you back to capital expenditure and operational expenditure. So when we're dealing with the cloud, you're not, when using public cloud, you're not actually doing any upfront investment. You're not buying servers that basically you are using them or not, you already paid for them. In cloud, you just operations. So you're basically paying for what you allocate. So I'm using a virtual machine today, I'm using some kind of storage. Next week, I'm not going to need that. I've just paid for it for 1 week, 1 day, or whatever that might be. And finally, the fifth point in there, we've got this. So this concept of pooling and elasticity, they basically tied together. So they tied closely together. So one with the other. So the resources are basically consumed very, very quickly, very, very efficiently, depending on the demand. And then, like I said, finally, the services, they can be monitored, they can be controlled, you can report on those. So providing you with this full transparency, what you are using, what you are paying for. So it's like this concept of pay as you go, or consumption-based pricing, we call it, where what you would consume, you only pay for those resources and you have complete visibility into what you are using and what you are paying for. So this is, in a nutshell, the 5 attributes or 5 pillars of public cloud. So how did we get here? So the cloud is here, pretty much. This serverless, let me just get my laser pointer here. So this is the cloud, which gives you a lot of capabilities that are fully managed as serverless. We're going to talk about some of the services. So at the beginning, big companies, they have huge demand for compute and for storage. So basically, they were building data centers themselves. So they have a lot of investment to put in the building themselves before even to go to get their technology in and get their infrastructure in there. So that wasn't kind of very, very efficient. So I think beginning of the 90s, a new business line came in, what we call these co-location facilities. So another kind of business strategy came about where companies will build huge, massive buildings. They equip them with networking, with cooling, with the internet. And companies, they come and they just basically rent the space. So they just plug in their equipment, basically bring the server, the networking is there, everything is there. So they don't have to think about anything, which gives them a lot of efficiency, a lot of flexibility into instead of investing into buildings, now they're investing in the technology itself. But that wasn't enough for companies to give them agility if they wanted to bring in new services and new applications. So in the physical world, let's say you have a new application that you want to deploy, then you will have to call somebody like HP or Dell or something. You need to do some capacity planning. You need to know what resources you need, amount of CPU, memory, storage that you need for that application. So there's a lot of testing even before you get to the stage what you need from compute perspective. You make the order to these companies. It's probably going to take you 2 or 3 weeks before you get it. And then this is the stage where you have to take it your data center, you plug it in, and so it takes a huge amount of time, very, very time consuming, not very efficient. So that was kind of hindered the progress and the efficiency, the agility of companies to bring and test services very, very quickly. I remember in one occasion, we are dealing with a market customer. We were using SAP HANA databases, which they require huge amount of memory and compute. So somebody made the order for these servers. So it took months, probably covered 2.5 months before these servers get customized and get sent to us and things. And it happens to be in that occasion, somebody made a mistake about the configuration for those servers. So kind of we lost 2 months. So they needed to go back, change configuration. So that's another 2 or 3 weeks, or probably even more. Then beginning of 2000 came this virtualized model. So virtualization, basically we are using VMs. So because companies needed more efficiency, which drove them to use virtualization. The components of virtualized environment or a virtualized data center are exactly the same. So you still have storage, processing, memory, network, but now they are all virtualized. So these are all virtual devices, separately manageable. If I need a VM, it's a couple of minutes, 2 or 3 minutes. I have a virtual machine with storage, with networking, and I can start installing a operating system. I can start deploying my code, testing my code, rather than waiting for weeks in that case. But still, the underlying infrastructure, I'm still kind of in the business of doing capacity planning, managing storage, managing infrastructure, managing patching operating systems. So it gave me a little bit of efficiency, but still in terms of agility and things, I'm still kind of, it's not giving me that enough elasticity to for example, scale on demand there and then very, very quickly. I'm still managing all the infrastructure. So cloud, moving into these serverless, fully automated models where you just bring probably your data, you bring your code, deploy it, and things like scaling, things like managing backup, storage, replication, auto scaling, failover, all those kind of stuff is taken care by these serverless, fully managed services. And we're going to take some examples in the cloud with that, which basically, like I said, I've talked a little bit about data here. So in some instances, you just bring your data. You have fully managed services. You can do data analytics, you do machine learning, and all the underlying infrastructure is taken care for you. And talking about data, if you think about one of the things that Google really is about when you start thinking about public cloud is that every company is a data company. And one of the things that made Google very popular right now is that they have so many tools to help companies understand their own data at a deeper level, providing analytics, providing machine learning, so give you that predictive power to basically give you the power, the edge over your customers to be ahead of competition and to making those business decisions in the future, taking kind of the company's direction with those business decisions into the right direction, and being kind of a step ahead of the competition. So there's many services and a wide variety of services for managing and getting value from data at scale. We're talking about petabytes, exabytes, billions of records that we can deal with within a matter of seconds. And this is kind of the different services that we have in GCP. Like I said, if you are using servers on your own application, on your laptop, you want to put that in the cloud, provide you virtual machines. We're going to see a lot of that today, and then varies on the other side of this continuum. We see managed services that completely do things for us, like pre-trained machine learning models, tools to do data analytics at scale, like BigQuery, for example, Bigtable, managed database services like Cloud SQL, Cloud Spanner. We're going to talk about those few of these very, very briefly. And in the middle, we've got serverless for developers. This is like more of a developer-centric models, cloud functions. These are event-driven piece of code that does a particular task, event-driven. So it is triggered by something, and it will basically execute that task within seconds and basically do nothing after that, which basically from cost perspective, you're not paying for a fully fledged server, you're just paying for the function when it runs. App Engine is another one that is kind of a developer-centric tool. We know that developers, they hate managing servers, hardware, and things like that. So they deploy their code into a server that runs everything for them, scaling, security, patching. So they want just somewhere where they run the code, and that's it. They don't have to worry about it after that. And then Kubernetes, if you are into the sphere of Kubernetes, there is a managed services for the GCP that allows you to run containers and manage the Kubernetes tool, which is an orchestration tool to manage applications of containers at a very, very large scale. So the idea of Kubernetes is basically, it's a Google technology that Google started with because Google has scaled at a very, very high rate in the beginning of 2000s and things. So VMs and servers was hindering their agility and to scale at a high volume. So just for your information, everything on Google runs on containers. They got their own operating system, which is called Borg. Borg is a container-based operating system, which this technology Kubernetes comes from. So back in the 2014, just to put it into perspective a little bit, Google, they were running 2.5 billion containers a week for all the services they provide. So that equates to something like 3,500 containers a second. That was 2014. So imagine now how much they would be running, or how many of those containers. So looking at the infrastructure, so we said cloud, like I said earlier, we explained what's cloud. Cloud is these metaphor of these data centers that are connected across the globe. Google, they've got their own data centers across the globe. This is a little bit out of date, so let me just bring in quickly here the up-to-date map of where Google exists, where they are growing and things like that. So can we see on this on the screen the Google Cloud locations, the cloud locations for Google? Yes. Yeah. Just to make sure I'm showing it. Okay. So here you can see this huge network that Google are building. And if you think about it, Google, they have, if you think about it, they got about 7 or I think 8 applications that are 1 billion plus users. So we're talking about things like Google Drive, Gmail, Google Search, Google Photos, YouTube. YouTube, actually, a couple of months ago, I was seeing something is like 2 billion active users on YouTube. So in order to manage this application at that scale with this reliability, Google have to build a very, very powerful network, a really, really strong infrastructure. So all those kind of stuff that are running, they run on this very powerful network. So they own this cabling. Google, they bought a company that does all these subsea cables, fiber optics at a very, very high scale. And they have got these data centers across the globe. So probably this is a little bit small. If I go down here, anything that is in blue, this is where Google exists. So they've got regions, North America, a lot of in Europe, South America. And you can see in the Middle East here, we have Qatar and Saudi Arabia, this big investments, these data centers or these regions are going to be opening soon. And you can see here more to come here. So I think a quarter, we have now 29 regions. 3 months ago, there were 24 only. So 5 new regions in the space of a quarter. And when we say a region, we're talking about probably $2-3 billion to build a region. So say a huge investment. So you can see here there is a big demand in the region for Google Cloud, and this is why Google are investing in that region. But still, there is a big skill gap in there. So it's a really good time to have those skills for the future, Google Cloud skills. Really. So this is what we're talking about here. All those kind of capabilities that Google are building. And I'll go back here. So this is the huge investment that Google are making, and this is where they organize those resources. So we've got the blue dots that we've seen. Those are regions, and the region consists of 3 data centers, and then you can basically provision resources. So I can this data center, for example, Europe West 2. I believe this is Belgium or UK, I think this is London. So this is London, Europe West 2, 3 data centers. So I can create virtual machines. So some resources, we call them zonal resources. So in a data center, I create virtual machine. There are regional resources, storage, for example. You can have a regional storage bucket, which means I create a bucket in one zone, it gets replicated across 3 data centers. So I don't have a single point of failure. If one data center goes down, I've got my data stored in multiple data centers, or even I've got what we call multi-regional cloud storage, which basically I'll have data replicated in 3 data centers and then replicated in completely different region as well, with through this very powerful network. So all this infrastructure that Google has built, not for the sake of Google Cloud, but for the sake of running those 1 billion plus or 2 billion plus users across the globe. And then a portion of those resources are given to Google Cloud. So Google Cloud customers like us today, we are using Quick Labs. Those resources will exist in one of the regions across the globe. And this is what Google Data Center will look like. Something like 3 data centers. They're completely segregated in terms of power and networking and cooling. So if power goes down in one data center, it's not going to affect the other 2. So you can fail over to another one. This is, I think, in the Netherlands. I think this one came back in 2018, something like that. $2.4 billion investment in that region. And pretty much we've seen those. So these are the regions and zones that are connected by this powerful network. Google is committed to environment responsibility. So if you notice here, this wind power is near the sea, so they can generate power from water. So very aware of about the environment. So very 100% carbon neutral since 2007. One of the world's largest corporate purchases of renewable energy, first data center to achieve this certification for the environment. And actually Google, they build their own servers, which are efficient for power. They build millions of their servers every year. I think they are the 3rd producer of servers after, I think, Dell and HP, I believe, are in 3rd position. So you can imagine the scale of the compute power that Google they have across the globe. Millions of servers across multiple regions, 29 regions across the globe. And for pricing as well, they offer multiple offers or multiple pricing models. They are the first providers to charge you at the 2nd level. So your bill, when you get it, you will get a 2nd increment. If you are using servers for a long period of time through the month, automatically you will get 25% discount. If you have application that runs all the time to run your business, if you entertain or you enter with in a contract for 1 year, 3 years with Google, they give you also long-term use discount in there. They've got some specific machines, virtual machines that give you 80% discount. We call them preemptible machines. And custom instance types. This is where you basically specifying how much CPU memory you want. So it's not like you have a selection of servers in terms of number of CPU memory. You do have those, but also you can specify exactly how much you want. So you're not over provisioning, you're not paying for things that you don't want neither. And also when it comes to open source, all the technology that Google uses is open source. So whatever you see in here on this slide, Google, they've got an internal version of that, Bigtable, which is HP based. Google, they run Gmail with this kind of technology. They made it available to Google Cloud customers through Bigtable. Dataproc is Hadoop. If you're familiar with Hadoop, it's another open source technology that Google has started. They made a managed service for it to be available for their customers. TensorFlow for machine learning, Kubernetes, talked a little bit about it. So very, very advocates for open source, which makes it easier. People think about open source. Yeah, okay, I'll join Google, so later on I can leave if I wanted to. So I'm not locked into that particular technology. But if you look at the other side of the coin, it also means it's easy to come to Google Cloud. So if I'm using Hadoop, I can come in Google Cloud to run my workload, and I can, if I don't need it afterwards, then that's fine. So these kind of things that we need to be aware of, which differentiate Google from other providers as well. And security, Google, obviously, they are very, very secure. There's a lot of misconception when it comes to security in the cloud, but a lot of stuff that Google looks after, like the data center themselves, the storage, the encryption, the communication is encrypted between all the services in there, the internet communication, a lot of stuff that is a lot secure than anybody else that could be using these kind of services in their own premises or as a consumer on their personal computers or anything like that. So when it comes to security, is about how to use the service. So if you're not looking after your username and password, for example, if you're making your data available publicly, that's not the problem of the cloud provider. It's the person who hasn't got the knowledge of how to secure this data with the tools that are provided for you by the cloud provider, either it's Google Cloud or Amazon, AWS or Azure. It's the knowledge that I need to have in order to secure my data in the cloud. So, like I said, Google Cloud Platform, super useful, super highly secure, scalable, reliable. Makes really good sense if you want to deploy your application, your services. Google Cloud is there with all those capabilities in there. So some of the services that are available, two things we're going to cover a little bit today is Compute Engine and Kubernetes Engine. So from compute perspective, and this is like the serverless, fully managed cloud function app engine that I talked about. From storage, like there is different services, cloud storage, for example, for anything that I want to store, like videos, photos. It's like the G Drive, but with a lot of more capabilities for enterprise use, for companies to leverage. And then you've got relational databases services like Cloud SQL, Cloud Spanner, document database, Cloud Data Store, or Firestore, we call it, similar to MongoDB. And Bigtable, another one that is a NoSQL database that runs Bigtable. I think the name says it all, is for big data. We're talking about exabytes of data, terabytes, petabytes, and millions or billions of records that I can store in such a database. And then for big data, there's a lot of tools available for us. Data analytics, I got BigQuery, messaging system like PubSub, data flow to do data transformation pipelines. If I want to clean my data, transform it maybe for machine learning. Hadoop, I've got a managed service for that, Dataproc. And data lab for data scientists for exploring that data with this kind of notebooks, AI notebooks and things like that. And then machine learning, a lot of stuff that you can leverage with these pre-trained models like Vision, machine learning platform to run your code, TensorFlow code, speech, translate, natural language processing, all those kinds of stuff. But hopefully in the future we get a chance to touch on those other topics as well. So this is like an overview of Google Cloud in general, what we can do, and cloud in general. Now we're going to move into our Cloud Study Jam, and we'll try to do some hands-on. But before I do that, is there any questions? This is the time. questions about cloud in general, about Google Cloud? Any kind of misconceptions? Because working in the cloud is a completely different mindset compared to what we used to do in on our servers, on our premises. So we need to a little bit change that mindset and understand that we are working in a different environment. Yeah, absolutely. Does Google give developers a chance to try this tech for free? Yes. So after the study jam, I'm going to show you how you can leverage those capabilities using Quick Labs. Yes. So there is. We're going to show you how to do that. And one of the things that we're going to be doing is part of today. You're going to get 1 month free access to Quick Labs, where we can use a lot of those services on your own. Absolutely. You're very welcome. So what I suggest we do before we jump into study jam, if we can take a 10 minutes coffee break. If we want to use Google Cloud, how we can convince the enterprise. First thing, you need to give me a call and I will come and convince them. No, seriously, you can just run a demo. So you can just run the demo. So maybe I can, when we do our first lab, I'm going to show you probably do a little demo just to create a VM, do some kind of operation very, very quickly. So things that you are usually to do in 1 week, you're probably going to do in 10 minutes in the cloud. How to start a career in the cloud. So I would rephrase this question. One thing that we need to be aware when we're talking about the cloud, it's no longer a matter of choice. Honestly, you either jump in and take the skills in the cloud. In this region, Middle East, probably we're not as aggressive now, but it will be. It will be very, very soon. We see Google Cloud are investing very, very highly in the markets. In the West, for example, in the UK, where I was used to be, now everybody is cloud. So you have to take the skills, otherwise you're going to be left behind. And the longer you leave it, you're not going to learn the skills, the larger the gap is going to be. So you're going to be left behind. Enterprises, they don't take the cloud. Economically, they're going to collapse. Student, engineers, somebody who's in the IT, if they don't have the IT skills, data scientists, researchers. I'm going to give you a couple of examples from what I was doing my PhD research to give you an idea the difference between somebody using the cloud and somebody who's not using the cloud in terms of efficiency and in terms of giving you that edge over to be able to do research very, very efficiently, very, very quickly, leveraging the cloud. What makes the cloud secure? Is how big is these companies? Google, you can see, in order to run a product like Gmail, for example, you have to be secure. So they've got the billions of dollars to make it secure, more than anybody else. Yeah, there is free labs, not just for students, but for everybody. For students, one of the things that you can leverage is your group, the GDG Sharjah. So, you know, they've got support from Google. They're organizing these events for you. Make the most out of them. You know, you need to learn. So you are ready for, when you graduate, you are ready for the market. So I'm not saying don't focus on your studies, super, super important. But in parallel, you need to learn those skills. So when you are, inshallah, graduated, you'll be ready for the market. If, for example, let's say you are graduating computer science and you have, you already have the skills in cloud with 1 certification or 2, people will be fighting for you on the market, honestly. So yeah, super important to get those skills. Yes, absolutely. It's yeah, we've seen it. We are in the market. You know, I work for many companies, and this is what happens really. This is the truth. There is no two ways about it. All right. Let's take 10 minutes coffee break, and let's get afterwards get our hands dirty with not literally, but you know, getting to start practice with the Google Cloud Platform. So let me put a timer here for 10 minutes. And in the meantime, while you're having your coffee, if you have any questions, put them. It's basically a community. Can you hear me? Am I audible?
Yes, we can hear you.
Okay, awesome. Okay, so Cloud Study Jams are basically a community events like what we're doing today, where we come together and learn together and practice together through a set of labs on this platform called Quick Labs. So Quick Labs is it's an environment where, like I showed you, you're going to give a set of tasks. They give you basically the steps that you need to follow. Very well documented to learn from. You can even take some of the notes, copy and paste in your notes documents to remember what kind of services are about, some of the tasks that we are doing. So this is what is part of this Google Developers Groups initiatives across the globe. So probably today there are you know, different countries running different study jams in different areas as well, and there are different tracks that we can have. So some of the tracks that you can have here, for example, we've got essentials. We're taking more some of that today, I think. So this is what we're going to be doing, starting with that. Some deploying applications in different environments. Cloud architecture, we basically take it to another level. There is a challenge. We're going to talk about challenge a little bit later. But like you see here, different tracks: security, Kubernetes, machine learning. If we get a chance to do some of those in the future as well. TensorFlow, we can see machine learning APIs that we touched a little bit on, the machine learning infrastructure, and then coming to data analytics and big data with things like BigQuery for data analysts, data warehousing, marketing analysts. Super powerful tool in Google Cloud, which is BigQuery. You can even do machine learning with just running some SQL statements using to create models, to train models for structured data. And again, just to give you briefly, hopefully everybody has joined the track. So let me just go back to and share this information for anybody who hasn't registered yet. And we try to do these labs together. So let me share the information again. So again, you should be chats and the code. So if you did run that first lab and it should have completed now. We have enrolled to that particular request. So now you should have credit or 1 month access to those labs. So if I go to study jam window again. Can you not hear me?
We can hear you.
Okay. Ahmed was speaking to me on French, so I didn't know what was that. He said, that son, whose son he's talking about his son is joining us or something, but he meant son, he meant voice.
Okay.
Okay, so what we're going to be, hopefully you you read some of that information in the tour. So basically what we're going to be doing first, we're going to go for this creating virtual machine. Again, we need to be in a incognito window. So if we open this lab, we go on start. So they're giving us 40 minutes. So we should be able to finish that in 20, 25 minutes, something like that. They always be generous with timing. And the reason behind they're giving us this amount of time, just to tell you, this is a real environment. Somebody is paying for those resources. So that's why it's, you know, you pay for pay as you go, basically. When you finish, everything gets deleted. So you're not paying for those resources. If you want to know how much is this cloud resources are costing, there is the Google Cloud calculator, one way to look at it. So I can go to this pricing calculator where you can estimate any Google Cloud resource to see how much it's costing. So let me just maybe take a little bit down this one here. So compute engine, I can select the instance that I want, and then the configuration that I want, and it will basically give me, if I just do that, how to estimate. So it gives me, for example, this one is costing me $50 a month if I use it constantly, basically for 730 total of 730 hours per month. If I want to be able to use it now and then, you can shut it down, start it again, things like that. So this is why I said I'm not doing upfront investment in anything. Okay, the link again. So let me send the link again. This is what I was saying earlier, to avoid this kind of issues now, but nevertheless, it's fine. So that's the link. You need to enroll in here. You need to run the first lab for 5 minutes or more, or leave it run, so you get the credits. The first lab, which is the a tour of Google Cloud hands-on labs. So at least 5 minutes, leave it run in order to get the credits for a month, free access. Okay, are we all at this point here? There you go. Usama, did you join late? Kind of. Okay, it's the first one. It's the, yeah. Create and manage cloud resources. Okay, if everybody goes to creating virtual machines, we are in a incognito window, starts, bicycle, whatever. So what you will get 2 options to run this lab. Let's skip. Okay, you will see an option here, subscription, use subscription. Instead of buy. Can you see the option use subscription at home? When you start the lab. Okay, good. So for those guys who have let the lab to run, this is what triggered this process of use subscription. So you will be using that option instead. I'm not asking you to buy anything. So let me log in with my This is how Google is secure. You've got two-factor authentication for the question that came earlier. So let's continue. Second block, virtual machines, start. Okay. Again, let me share the link. We are still having some of us here a bit behind for a reason or another. Again, this is the link you need to go to. And this is the code. No, it's fine. It's fine at the time. And then you need to enroll into the first one, create and manage. Create and manage cloud resources. That's the title. Start the first lab to run at least for 5 minutes. And when you start the lab, use subscription. Okay. Let me wait for a minute or so for everybody to be on the same here. Start the second lab, creating a virtual machine. And for each lab that we're going to be doing, you will have a different username and password. So all those resources they're going to give you in Google Cloud Platform, they are allocated to a user here. So it's not your Gmail account that you logged into QuickLab or you register to the Quest or to StudyJam. But each lab will have a username and password specific for a particular project that will be created in QuickLabs. So you're going to do, you open the console. If you haven't opened the console in a Cognito window already, you can right click. This won't be grayed out. You can open link in a Cognito window, but in our case, I think all of us have opened it in a Cognito window. You open the console and then you copy, there is this button here. You copy the, you copy that. In the username, copy the password. With the button, you click on that button, it will copy for you. I think it's easier to do that than trying to select and paste, because sometimes you add a character, you miss a character. So this copy paste button or copy button here makes this this thing easier. So I can copy the password, paste it. And now this is the Google Cloud Console. Are we all at this point here? Are we all on the console now? Are we all here? Are we all good? Okay. Okay. Once we are here, this is our dashboard. So we give you the information about the project. So project, this is what created for us to create these resources. So it's like a container where I'm going to be able to create resources. The billing is going to happen here. So somebody's going to be paying for that. So you can here, if I go to this view billing here, for example, you can see for my projects, I haven't used anything yet, but somebody's going to be paying for those resources as we go along for the rest of this, basically, the amount of time they gave us, 1 hour, 40 minutes or whatever. We're going to see how much consumption, get us some dashboards here, really, really good. So I can go back to the console by clicking on Google Cloud Platform. I can see my project. Make sure you have this selected here. Make sure you've got, when you see Quick Labs, this long name here, make sure it is displayed here. Otherwise, you're going to have issues if it's not selected. It tends to have, if that's not selected, what you can go is go to this button here, drop down, and go to the All tab, and it will be the last one that you need to select. Select that, it will make sure that you are on that lab. So you will have many, many things here, billing, monitoring the resources. How do I access resources from here? It's this hamburger menu here. And here I can go for VMs, for example, compute engine, to see what I'm going to be using. Anything that I will be using so frequently, because there's so many services here, I can just scroll down forever. But if I want to access something very, very quickly, I can just pin it to the top. So I can do pin. And what happens, that service would be right at the top with these services. So I can, there's some of them are pinned already. So if I go back here, there you go. I am. For some reason it's not. Pinned. Yeah, there you go. So it's pinned at the top of the menu. Okay, so let's see what we're going to be doing in this lab. So creating a virtual machine. I'm just going to go slow here. So please just stop me. Like I said, you will have an overview what compute engine is. It's kind of basically virtual machines that we're going to be creating. Different operating system that I can select from, different hard drive, different options. So here we're going to be using, we're going to be creating a virtual machine with a cloud console. We're going to create it with a command line, and then we're going to deploy a web server and connect it to a virtual machine. So we started the lab, like I said, we opened that, we did sign in, we accepted the terms. This is the hamburger menu that I talked to you about. There is another way that I can access anything with this search button here. So if I wanted to make this a bit smaller, so I can type here compute engine, and I can go to compute engine directly from here if I want to. Okay, the second thing that you get to the console is what we call the cloud shell. So anything that we can do from the console, this clicking buttons and things. At the back end of it, what's happening is taking this command and executing it. So it's taking an API call and executing that command, having like a JSON format for it and tell Google to create that form. I can do that with a command line as well. And the command line, basically Google are giving it this, what we call the cloud shell. So let me see what steps are we in here to do that. Are we doing the cloud shell yet or not yet? Okay, so we're executing the cloud shell. I'm going to come back to the cloud shell in a second, but what we're going to be doing first is task 1, create a new instance from the cloud console. So we're going to go to the navigation menu, hamburger, compute engine, VM instances, create an instance. And that's going to be this one here. So we went to from the search menu. I can go from the hamburger menu as well. Compute engine, VM instances. Are we all here? Are we all at that point? Okay, we click on VM instances. And then we go create an instance. I need to do exactly what they told me when these regions and zones and things like that. I need to be exactly the same. So what they're telling us here before I go through that, I talked about regions and zones earlier. So regions are basically cities across the globe where Google have these data centers. And the data centers, we call them zones. So each region have got 3 zones, except for US Central 1, they've got 4 zones. US Central 1, Iowa, this is where the 31st Google data center back into the 2006, they built it in there. And then from then on, they started building those regions, and each region have 3 data centers. So in here, they're asking us to use US Central 1, surprisingly, and we need to name it GCE Lab. Okay, it has to be exact configuration like they're telling us here in the exact zone. If I try to do something any different, if I do a misspell or try different virtual machine, when I go to the step, when I do check my progress, even though I can see a virtual machine is running, the web server is running and everything, but it's not gonna accept my progress. It's gonna give me a red sign here. So I need to be doing exactly the same as what they're telling me here. So I go and give it a name, GC Lab, like that. Make sure I'm not leaving any spaces. US Central 1, F. So you see, like I told you, this one has got 4 data centers. If I select anything else, let me go to US East 1, for example, you will find 3. So only US Central 1, that it has 4 data centers. I'll go with F, like they told me. So this virtual machine, it is in the one data center of those 4 in US Central 1, which is Iowa. And notice here, I'm having already an estimation. So if I go with the default, this virtual machine is going to cost me $25.46 per month. If I select another region, if I take this, I want to create it in Europe, London, for example, West 2 that we've seen earlier, 3 data centers, select one. It's more expensive in London, right? You can see $32 in there. So just be mindful of that as well. So going back, US Central 1, F, there you go. Okay, are we all up to date? And then they told us N1, 2 vCPUs, 10 GB drive, allow HTTP traffic. So I think all those are the defaults. So N1 series. So I go here, N1, 2 vCPUs, which is the next one. So you can see here, I've got a very large selection that I can go through. But the example I gave you earlier when I said like custom VMs, let's say I've got an application to run. Just because I'm here, I just want to highlight this because this is unique to Google Cloud. You don't find it in any cloud provider. So let's say I'm here and I've done some capacity planning and analysis. And I know my application needs 10 vCPUs, for example, 40 GB RAM, let's say. So I come here and I'll find 8 vCPUs and the next one is 16. So if I go for 8, I run my application and I'm having performance issues. The application is hanging, slow, users complaining. So I have to go to 16. Yes, the application would be running great, no problems, but I'll be paying for stuff that I don't need. I'll be paying for 6 vCPUs, 20 GB RAM that I don't really need. And for that reason, Google are giving it this custom machine. So with custom machines, where I can go, I can just use a slider. So I can say, okay, give me 10 vCPUs and give me 40 gigabyte RAM. And this feature, you only find it in Google. So Google Cloud will create a virtual machine with this amount of vCPUs and RAM. So we'll keep to what they told us to do, 2 vCPUs, N1, and then Debian GNU Linux 10, I believe. Debian balanced persistent disk. So in here, I can change my my operating system, but I'm going to leave it to that. But you can see you've got a very wide range of selection when it comes to operating system, Windows, different flavors, Linux or Linux, containers if I want to run containers. I'm happy with Debian, balanced persistent, like they told us. I can use SSDs or standard depending on performance that I want. So let's keep up what they asked us to do. 10, select that. And this is going to be like this is going to be a web server. So they asked us to allow HTTP. So allow HTTP traffic. I'm just going to click here. What this is going to be creating a firewall rule for me to allow traffic coming publicly to this virtual machine, because it's going to be a web server. And then they're asking me to click on create. Okay, I'm happy to do that. So are we all good before I press create here? Okay, anybody having any problems? Because I won't be able to go back to have the same window as anybody else, except if they can be sharing their window, their screen. Okay, with this configuration, obviously we are going with the default. They didn't ask us to change anything, but I can change if I want to. If I've got a specific operating system that I want, I can just go to change. I can select the operating system from any public images. I can use Windows if I wanted to, Ubuntu, SQL Server, different options in there. And the persistent disk as well, I can use SSDs, local HDDs, can change the size. But really what you're going to be doing if you are in your organization, you're not going to be using the public image. You will have your own application already baked in the operating system. You're going to be basically bringing your own image and selecting it to do that. You can also use snapshot existing disks. So this is, we're going to cover that in the future. Hopefully the future study chats or sessions, we're going to have more advanced configurations. Okay, so we're happy with that. Then anything else stays the same. And I'm going to just go and create. Okay, just a comparison here. If I compare, for example, Google Cloud with AWS, when you create a VM, it does take minutes. No, nobody's going to be paying anything. Somebody's asking me in the private chat is that VM is costing $49. How are we going to be paying that? No, that's the whole idea, that we are giving you those. Somebody's having a heart attack here. So this is the study chat to give you the credits to be able to do that. So let's hide this info here. So our machine, like I said, if you compare that to the AWS, for example, AWS create a virtual machine takes minutes. And within 20 seconds, we've got a virtual machine ready for us to use. Okay. So now we can SSH to that. This is what they're telling us to do after that. So we're going to do SSH just to log into that machine. Again, I don't have to create a client and create a private key, the public key, and all that stuff. Google have streamlined this process for us. managing all that well. So when I do SSH, what you will notice here, connect, and it's doing all that, establish the connection, using the keys, and I'm within 10 seconds, I am in my virtual machine. So let me make this a little bit bigger. Largest. Okay, so it's here on the screen. Everybody is able to SSH to that virtual machine. Are we all in? Let's dismiss this. Okay, awesome. Okay, this process, if you are in your own company, you wanted the VM, and you need to talk to service desk, a couple of days to somebody to log in the call, keep you updating. We've got your request, we are dealing with it. Expect they give you an ETF for 24 hours for the next updates, for a couple of days where you completely lost hope of what you wanted to do. So here within 30 seconds, we've got a machine, we've got ready to use it with all those capabilities, our images, our disks, and the rest of it. Okay, going back, what we need to do, we now need to install our Nginx. So here again, I don't expect you to be typing those. I don't want you to go like this, copy and paste, use this button here. The copy button, go back to your SSH session, paste it in here. This is basically giving you sudo access to your VM. Basically, you are the root, you have root access, so you can install things. You are the admin, basically. Other than that, you won't be able to do that. Updating the OS, again, second command, click on the copy button, go to your SSH session. We're updating this package because those images, you know, the kind of Linux, they update, they patch those. So the image is available for us, but probably it's been uploaded to the Google Cloud maybe a month ago, or they got like an update for these things on a regular basis. But basically, maybe there was a patch that was done yesterday, last night. So we need to update that image that we have done. So now we have done that. Do a clear, so we've got clear screen here. And next, I'm going to install Nginx with this command, apt-get install Nginx -y to accept, you know, basically that it responds what we do with that. So we accepted that, and it goes through all that process for me. So that would be one of the demos that you can do in your organization, just to show them the power of cloud. If they're not cloud savvy, they don't know the benefits, they might be giving you some kind of task that you need to do, and you do it on the cloud, and you go show them, look, this is how long it took me to do it on our infrastructure, and this is how long it took me to do it on the cloud. That would be one way to do it. Okay, again, we've got Nginx installed. And then let's confirm that our Nginx is running by running this to run what processes are running on our virtual machine. Yes, and then we're gonna grab the Nginx, and you can see that it is actually running with these processes like this. All right. Anybody having any issues? Okay, great. Awesome. Really, really important when you are doing these labs. I need to understand what I'm doing, okay? I need to read what is the step I'm taking. I'm SSHing, I've created the virtual machine, I selected the disk. So it's not a matter, because when I go down here, okay, I'm gonna go back here, I'm gonna show you something when we go back to our virtual machine. So this is the external IP. You're going to click on it. Okay, you can see my Nginx is running. So I expect you to have understood the steps that we have taken, because if I go back here, check my progress, it's green, okay? Assessment completed, I've got 50 points up to this point. So the thing that you need to be aware of as we go along and you're on your learning journey, when you're gonna do these labs, these quests and everything, it's not about getting this green and not understanding what I've done. So this step, I need to understand what I've done here, the steps that I'm following. There's no point for me coming down, finishing 100%, and then I didn't actually understood what was happening. How did I create a virtual machine? What are the disks? Why did I click on that firewall rule? You know, how did I SSH in? How did I install? Okay, all those kind of stuff. So I need to understand the process, what I'm doing, how did I create from cloud perspective at least. I don't expect you, because this is simple lab, but if they give you something in Linux, not that much that I want you to understand, you know, this is basically command to install. I didn't expect you to know that, but at least for creating the virtual machine, selecting those options, going through the console and things, I know this is how to create a virtual machine, how to SSH to it, the capabilities that the console is given. So have we got everybody at having this progress, having the Nginx server running? Okay, great. Okay. The next thing we're going to do, whatever we've done now through the console, we're going to do it on the should we get the same numbers as the outputs? What do you mean the same numbers as the outputs? I don't get that. You mean these, the external IP? Or what do you mean by that? No, this is the IP addresses. Each machine is going to have its own. Okay, so virtual machines, they have IP addresses, like your laptop that you're going to use is got an IP address to access the internet. So this server, each one is going to have its own. So mine, it's going to be 34.124.4103. Yours is going to be different. This is your address. It's like your home address. Nobody's going to have the same as your home address. So this virtual machine is identifiable over the internet with this particular IP. Okay. Yes, please put those questions to clarify any misunderstanding, misconceptions. Let's clarify those doubts. Okay, because we all started somewhere. Nobody knows everything. Even myself in these sessions, I learn new stuff from students. When they put questions, they bring something I didn't know before. So we learn from each other. Okay, so we've got that. Next, we're going to create that with the command line. Like I said, anything that we do from the console or the command line, at the end of the day, it is a REST API. So the developers at the back end, if they wanted to create that, they will run, they will create something in JSON and basically send that to Google Cloud to be fulfilled. So the JSON file will look something like this. So if I go back here, don't want you to do this, just to show you what it looks like. So if I look at this, if I go back down here, what you will see, the equivalent command line. Oh, they used to give us the JSON format of that. They just given us the G-Cloud, so not to worry. Okay. I might find something. Let me show you what it looks like. Computer. So developer, if we want to leverage Google Cloud Services, they don't want to use the console, the command shell. They interact with the Compute API directly So I can, where is the, there we go. So they will be sending commands like get, list, delete, inserts. So if I go here, for example, instances, if I want to create, developer want to interact directly with the API, they want to create an instance, they probably go with, is it insert or is it touch disk? Or is it, 1 second. Update stop starts. Yeah, I think it's an insert, to insert a new, I'm not mistaken. Let's see, template image. Yeah, so this is the JSON representation. So this is what developer will be sending. It's pretty much a bit complicated. Developers need to provide a value for each of those disks, labels, and the rest of it. So basically what we're doing in the console or the command line, we're filling in this JSON representation, and it will be sent to the compute engine API. It will understand this format and will create a virtual machine for us. So now, like we've done that with the console, we're going to do in the command line. The command line is basically when we do activate the shell. So I want you to go to this button here, like you see right up before the question mark, and activate the Cloud Shell. And activate Cloud Shell, what is doing for us, the Google Cloud Console or Google Cloud, they're creating a virtual machine, a small virtual machine, with all the tools, the SDK we call it, with all the tools, the command line tools that would allow us to create virtual machines. So which called the gcloud command is part of this SDK. We have gsutil to talk to the Google Cloud Storage, and we've got also what we call BQ to talk to the BigQuery service in GCP. So here they're asking us to use the gcloud. So again, we can copy this command. So we have, like they tell you here, instead of using the console, we're using Cloud Shell, which is a Debian-based virtual machine loaded with all development tools, gcloud, Git, gsutil, and they give us a 5 GB drive in here. And this virtual machine they give us is completely free. So it's not part of what we're going to be built for. They always be available for us. So what we're going to be doing, we're just going to copy that. Click on copy. Okay. And we're doing this from this Cloud Shell. Don't go to the shell that we went to SSH or the other virtual machine. We are in the console. We're using this shell here. Paste that. And again, we are creating in US Central 1F, same as the other one, and one standard, which means 2 vCPUs. Yeah, it's the Cloud Shell is this button here before the question mark. Activate that, click on that, it will open that for you. Okay, are we all at the shell? Anybody having any issues? The shell hasn't opened or... Okay, we press enter. What this command is going to go, it's going to go gcloud, which is the command compute, which is the compute engine service. Instances, because at the compute engine we have different services. We are specifying we want instances, we want the VMs. Create the name of the VM. Machine type is N1 standard 2. Pretty much same to the other one. 2 vCPUs, 2 GB RAM, I think. And the zone, the data center where you want to create that. Press enter. It's going to ask us to authorize. And if I go to compute engine on top here, look at my instances. Pretty much within 10 seconds, I've got a second virtual machine running. Look at that. GC lab, GC lab 2. Okay. I've got a different virtual machine here, a different IP address. Notice this is a completely different. So yes, so this tab, Lulu, is from if you you see this question mark I'm pointing to. Can you see that? Before it, there is this button here which we call the Cloud Shell. So Cloud Shell, when you press that, it's gonna open this shell for you, which is basically Google Cloud will create a virtual machine with all the tools that will allow you to create virtual machine and manage virtual machine instances, which is the G Cloud. Once you do that, you will get this shell here. From the lab, you go to task 3, and this command here, you copy using the copy button. Go back here and you paste it in here, and it will create a second virtual machine. So now we have 2 virtual machines here. Got 2 virtual machines, 1 and 2. If you go check progress, hopefully you will have second one already there. Let me see if there is any questions, any clarifications we need to make up to this point. Are we all good? Are we all having 2 virtual machines running? Yes, so this is another way. So we can create we can use the console, or we can use, if you are, you know, very kind of savvy and we like typing and things, we can use the shell and use G Cloud to create virtual machines. And now I've got 2 virtual machines. If you notice, I've got the other shell still open. I can ping, what was it, GC lab 2. And then they can talk to each other in there. And notice, because they are in the very same data center, look at latency, 0.2 millisecond. The network is super, super powerful. 0.2 latency in the same data center is huge. If you try to do that, maybe you have 2 machines on your network at home or at university, you will understand the difference in here. One other thing, maybe you try to do, if you are doing other labs later on, besides the study jam, when you are here in creating anything in here, please do follow the configuration they ask you. Don't try to go and say, okay, let me try. They ask you to 2 vCPUs, and then you go say, oh, let me go for 8 vCPUs. It will create a virtual machine for you, but there is a script as part of Quick Labs that it checks. If you over provision, your account gets blocked. They will block your account. If it happened by mistake, or if you tried something and you realize that your account is blocked, what you can do, just go to this chat window here for help, chat support, enter your name, the email address, the department, Quick Labs General, or is there one for study jams? No, there isn't. Or the 30 days of Google Cloud, or Quick Labs General is fine. Just ask them to unblock your account. They will check it. They will tell you that you over provisioned something, and they will unblock your account. Just to be mindful if things that happened. Don't panic. Nobody's going to ask you to pay anything or anything like that. Just ask them to unblock your account. But you know, just for your kind of progress. If you try to do that all the time, then it will basically hinder your progress, and you always ask me. Just be mindful of that as well. Okay, so we've got 2 virtual machines. We can SSH. I can even SSH from within that virtual machine. So, like they're telling us here, so I can go and from one, I can from within this one. Let me Control C, clear. So earlier we SSH to GCE Lab 1 or GCE Lab from the console. Now I'm within that second virtual machine because they are on the same data center, the same network. I've got the firewall rules allow me to do that. I can log in from one virtual machine to the other. Now to that, I go yes. Passphrase, I go with blank, blank again. Insufficient authentication. Just did I miss something here? My lab is finished. See, because we took too much time now, my resources have basically finished. But hopefully everybody got 100%. We took our time to do it step by step and things. So now, because of my resources have been basically gone. So hopefully you will see a green tick against your created virtual machine that we've done here. Have everybody got green? 2 greens for the 2 labs? Okay, brilliant, great. Okay, there is another lab for Windows. I'll let you do that on your own later. Our next lab, let me see. We've got getting started with the Cloud Shell and G Cloud. Let me see what we've got here. Maybe we can do the Kubernetes, because I'll show you a little bit about Cloud Shell and G Cloud. I'll let you do that later. So this lab is 30 minutes. So the next one we're going to do together is the Kubernetes engine. Okay, are we all up to date here? Yes. Okay. So we've done a lab, we went over 40 minutes or so. What we will do, we'll take another 5 minutes break, just to, especially we are all new to cloud. I don't want to overwhelm you.
No problem. We can take 5 minutes break.
Okay, let's take 10 minutes break here and come back and do another lab.
Sure.
Are you familiar with Kubernetes or work with Kubernetes, work with containers? Okay, just a couple of minutes. Yeah, Docker. Okay, for the benefit of everyone, so Kubernetes is, like I said, the technology started by Google. If you've noticed when I was working here, this is not going to be working. because this is gone. My right console here. Just quickly, if I go to the console, probably I showed you when I'm creating a virtual machine, I can deploy a container on a virtual machine. So I can, just to show you what that is. So a container is basically an abstraction of all the operating system, of the hardware where the application is going to be running. Or we're gonna do future sessions where we're gonna talk that in details. But in essence, what containers are is basically, if you take, for example, virtual machines, a virtual machine, we are abstracting, we're virtualizing the hardware. So in the same hardware, I can run multiple virtual machines. So the virtual machine can run as if it's running on its own hardware, but in essence, it's basically multiples running on the same server. Containers is another layer of abstraction that we take in. So we are virtualizing the operating system itself. So each container running on a cluster on a virtual machine thinks that it's running in its own operating system, whereas it's on the same operating system, we can run multiple containers. So we're sharing resources from the same virtual machine. So here, if you look at creating virtual machine, if I go, probably you've seen that option where I can directly have an optimized operating system with Docker. So in here, deploy a container. This is what it does. I'm just going to specify where my container is. And this basically will give me an operating system with Docker installed and my container running on top of that. Or I can do, if I can change here, you can see container optimized operating system. Okay. So I can select that and deploy my container in there. So running one container per virtual machine or two containers is easy enough. I can maintain that. But when we're talking about scale, if you look in the Google, for example, I told you 2014, they were running 2.5 billion containers. So you don't expect somebody to go to virtual machines or a cluster of machines and try to deploy those. If one fails, it will create it. And so they wanted the tool. They wanted an orchestration tool to do all that automatically. Deploy containers, manage security, communication between these containers, manage the storage with them, deployment at scale. When you want to bring new versions of those applications, it does it for you in a consistent way and things like that. So Kubernetes is the orchestration tool that does that all for you. But an orchestration tool of the scale of Kubernetes is a complex beast. So there's a lot of services that I need to manage. If we want to find out how complex it is and you want to do that on your own, this guy is Kelsey Hightower. If you Kubernetes the hardware, so is this one. So this is this repo. If you want to create your Kubernetes cluster yourself, let me share this. It's a beast. You need to know your stuff. There's a lot of things that you need to do, but this is a step-by-step. But it is hard. It is hard to create a Kubernetes cluster. Sorry, I put it direct message. And it's even harder to maintain it after that. And for that reason, Google have created a managed service for us, which is GKE, Google Kubernetes Engine, which means when you create a cluster, Google will install all the components, it will manage it, it will maintain that. So that's the general idea behind having what we call a managed service. So you can deploy your containers into a cluster, but that cluster is managed for us by Google. We do have access to the nodes where we create that. And this is what we're going to be doing in this particular lab here. So if we go to, let me just close all those because that console is not there anymore. So we're going to the Kubernetes Engine quick start. If we click on that, start the lab. Again, you're going to be using the subscription yourself. Let me know if you have access to that. Okay, are we all good? Have you all started the lab? No issues with credits and things like that? Okay, great. Awesome. It's going very, very smooth. Some study jobs, we do have issues after the first lab, that people saying, okay, asking us for credits, but this time is really good. And I think the reason, because we started the lab and we didn't know the stuff, and it did provision the credits for you as it should be. So open the console. Okay, again, same thing, copy the students, copy the password. Going to next. We're having the password and we're having a completely new console. So the lab that we've done earlier is a completely different project. The project name is different, the username is different. Now we're having a new console, new project, and new resources for these Kubernetes. So again, if we go down, like I said, they give you an overview of Kubernetes, orchestration, like I said, for Kubernetes, and a few of the topics that are in here, but they take you to the documentation. But other than that, same thing to access. And these steps here, we can open the shell and just to verify our access, our user account. So I can go shell here. We're getting the virtual machine created for us with all the tools, the G-Cloud, the GSUtil. And okay, the first command we're running, just to make sure that we're logged in with the right account. So let me just take that out, close that, close that. You can see G-Cloud auth list, just to make sure that I am logged into the right project and the right account. And yes, this is the account. If I check it against the Quick Labs information, the one that finishes with 388. It's exactly that, 388 at quicklabs.net. Okay. The project that I'm working on, G-Cloud. Yeah. It's just listing my credentials, my projects. Okay, so some students receiving note that the course asks for 1 credit, but is there any credit for them? It should have given them 5 credits, I believe, so they can use 1 credit out of the 5 remaining. Again, this is the project that we're working on. That's absolutely fine. Okay. Are we all good with the credits, or do we need to? Okay. Let's say okay, they say silence is golden, so I take it that no issues. I did realize my camera was off. Okay, now what we're going to set the default zone. So the reason we do that, so we don't have to enter that zone later on in our commands to specify the zone. So we go G-Cloud config set compute zone U Essential 1A. So basically, if we create a cluster, it will automatically go and create it in this data center in U Essential 1, which is the U Essential 1A data center. So I'll go and make that as the default for my configuration. Okay. Okay, again, there is two ways to create a cluster. I'm just going to see here if there is a way, if they're doing it all command line or... Okay, it looks like all command line. Okay. So in here, there is also two ways to create a cluster. In here, we're doing it in a command line. So we set up our default zone. But if I didn't set it up, what I can do, I can use Kubernetes engine here, clusters. Just don't do that. I'm just showing you where you can create it. I can go create. Hopefully in the future, we do one study jump completely specific for Kubernetes and we go through all these options. But here we're going with standard. And here, give it a name. And in here, like I said, we can select US Central 1A and do the other configurations. So the other configuration, they ask us, basically going with the default. So what I can do is here, they're asking you to use your own cluster name. It doesn't matter. They're not giving you a specific one to use. So you can use, instead of this brackets cluster name, when I copy here, when I paste it, I'm just gonna scroll back here. Okay, send it. Call it SHG GDG cluster. Okay, for instance. So it's going to create the default cluster here. What it's going to do is a Kubernetes cluster consists of multiple servers. We call them nodes in the Kubernetes sphere. You will have one master node. This is the brain of Kubernetes. This is all the components that deals with the Kubernetes orchestration. And this is completely hidden from us. So that's in the Google network. They manage that. And then the default is actually 3 nodes. So 3 servers as part of this cluster. So when it goes and create this cluster for us, if I go and check here, so like I said, I can use this using default using the command line or the console. But in this case, let me go back and check what is my clusters. So you can see here it's creating clusters here. So I've got 3 nodes. Yeah, you just give it any name. It doesn't have to be cluster name. So just give it a name. Delete, brackets, cluster name, and give anything in there. Test, default, your name if you wanted to. So anything. That doesn't have to be anything specific. So in here, you can see my cluster. So if I go to VMs, for example, instances, because we said the cluster is a set of servers. So if I go to VMs, what you will find in here, you will find 3 nodes. Like I said, the defaults, I can change that configuration if I want 5, I want 6, but if I don't specify the number of nodes in the command line or in the server, it will create 3 for me. So you can see here 3, we said the cluster is actually a master node and a number of nodes. So the worker nodes are created for me. There is a master node that's completely hidden from us. That Google is looking after. It's not in our network here. So this is what we call is a managed service, GKE. And go back to my cluster here, and it's still creating it. So we've seen that the VMs themselves have been created, but now what it's doing behind the scenes is managing, configuring the master node, all those components that needs to happen. And the master node, this is why it's taking long. But my cluster is ready. My VMs are ready. We're just waiting for the final configuration of the cluster itself, of the master node, the brain of Kubernetes. So while it's doing that, let's see what other steps we've got here. So we created. Let me check progress. Probably it's going to give me red. Yeah, it hasn't finished yet. Back here. We'll wait for it. While it's doing that, is there any questions? Are we all at this step here, creating the cluster? Are we waiting? Everybody waiting for cluster to complete? I can check these nodes from here if I wanted to. So I can go and click on there. And you can see configuration, deploying, doing some health checks. I can check my nodes from here. 3 nodes in the default pool, and it's pretty much done. So my server is done. My cluster is ready now. You can see that. Awesome, good. So everybody's in there. Check progress now. Hopefully you should have green. Everybody should have completed this step. Now, in order for us to authenticate, basically we have created the resource now. We want to log in inside the cluster to do operations. So anything outside the cluster, it's considered to be a Google Cloud resource. So anything to do with the Google Cloud resource, we're using G Cloud. So we are outside the cluster. So we need to authenticate inside with this command. So I can bring this command here and let me just clear, or even I can open this in the complete window. So I can go like this with this. You can see there's this button here. I can make it large. So the Cloud Shell is open now in its own window. Oops. Button this. So, and I'm going to do authenticate. I think I called it this. Let's start. Okay. Okay. You should have this command, Spreadsheet Cloud update and cluster endpoints. We generated the entry. And now, inside the Kubernetes cluster, because we are dealing now with Kubernetes, we're not dealing with the Google Cloud resources anymore. Now is the resources we're going to be reading like Kubernetes resources. So for that, we're going to be using kubectl. So kubectl now, we're going to allow us to deploy our application to have like containers. So we've got a container image here called hello application. So the way we deploy it is using kubectl. So I can pretty much run this command, kubectl create deployment, give it a name, and the image is in this repository, the Google Cloud source repository here, or container registry, sorry. So I can go there, paste this, and now I'm deploying an application into container. The image of the container is, this is its location. So similar to when I created the virtual machine, I could have used the created virtual machine and deployed this image directly to a container, to a virtual machine. So here I'm doing it as an object in Kubernetes called the deployment using kubectl. Okay, so from the command, and did it give me that? Yeah, so it tells me the deployment has been created. Are we all good? Anybody having any issues? Let's slow down a little bit here. Okay, so my application should be now running into Kubernetes. If we check our progress, Okay, we should have all green, assessment completed. Now, let us understand this a little bit. We said the Kubernetes cluster is a master node and 3 nodes. We deployed an application in it. The application, it will be in what we call pods. Pods is an object in Kubernetes where the container sits inside it. But we won't be able to access it externally because it has private IPs, not external IPs like we had with the VMs earlier. So in order to access it, our user is going to access the application from external. I'm just going to very brief here, but hopefully in future we'll specify something session completely about Kubernetes when we talk about the details. We have to create what we call a service. So the service will be something like creating like a load balancer where we have an external IP, like we've seen the VMs earlier, where we can connect to that external IP from anywhere and access our application. And this is what we're going to do with this expose command. So expose, and we're going to type a load balancer, and it's going to create an external IP for us. We'll be able to access through port 8080. So if we copy that, go back here. Again, because we are doing now with Kubernetes object, we're using kubectl, we're not using gcloud. We're creating a Kubernetes service. So now it's telling me this application is exposed, meaning it has an external IP. So if I go to, let me see, services, if I want to see that, there you go. You will see that I've got a hello service created for me, external load balancer. That's the IP. External cluster IP. Sorry, that's external IP. Sorry, that's the internal IP, the cluster IP. This is the Kubernetes cluster. The endpoint IP is this one. Everything is running. CPU now is up. If I want to see the external IP, which will be something like that, I'm going to run this here. And this is my external IP. Now I can access externally from here. So I'll let you run this command. While you do that, I want to see that external IP from the console. There you go. Yeah, earlier we couldn't see it because it was still creating it. So I can actually go from here, and there you go. So you can see here that my application is running. Hello world application versus 1.1. This is the server, the host name. And exactly, I can do it from the console, or I can just go and type get external IP 8080, which is exactly that, what we've done here. So you can see the external IP that we got from the get services, kubectl get services. We want to access it through port 8080, and this is what you get. That's the result. Check my progress. Okay. Have we all managed that? Okay, I just want you to think, imagine you're doing this on premises, you're creating your Kubernetes cluster, how long it's going to take you, the hardware that you're going to need, the help you're going to need from storage, from somebody with networking skills in your organization. It's a big project in order to do that. Now, we started probably 10 minutes, and we have Kubernetes cluster, we have a web application running, our users are accessing it within 10 minutes. And this is awesome. This is super awesome. This is the power of cloud. This is what I was saying. Companies, organizations that are not going to embrace cloud, without any doubt, they were going to collapse, without any doubt, because competition is fierce out there, and they're going to be left behind. You know, your competitors are deploying applications within 10 minutes. You are deploying them in weeks and months. How can you compete in the market these days with such velocity of deployment? All right. Any questions? Any issues with the lab? No issues. Are these normally the same steps we need to follow? The steps to deploy, yes, absolutely. So if you have your own cluster, for example, not specifically GCP, anything kubectl, any commands that you run on Kubernetes with kubectl is exactly the same, whether you run them on your laptop or you run them on AWS or Azure or Google Cloud or your on-premises Kubernetes cluster is the same, because Kubernetes, we said, is an open source technology that is the standard for deploying containers these days. So yeah, it's exactly the same steps. You are very welcome. Okay, any other questions? All right, so what other labs have we got here? Okay, the next one, we're going to delete the cluster. So there's two ways to do it. I can run this command here, gcloud containers cluster, if you have seen that, or I can go to the console and I can delete it from here, or I can run like they told us, and I specify the name. And this is the beauty about cloud. I finished my process, my application, don't need it to run anymore for another month. I can deploy a cluster next month if I wanted to. I haven't spent any money upfront to buy those servers and create those servers and anything like that. So now I'm not going to be paying for anything unless I'm going to use needing that cluster again. Okay, deleting. Check, probably still deleting. Let's check. Clusters. Check check. Still deleting the clusters. Yeah. So there's few components to stop the service, delete the service that created, the load balancer, delete the nodes, delete the master node, all those kind of stuff. They happen in order. And but it's all managed for me. It's not. Okay, any questions? Are everybody up to this point? Have we all done these steps? Okay. Good. You've done really well. I'm really impressed with everyone. Following the steps, understanding. Really good. Well done, everyone. Okay, we'll wait for this cluster to be deleted. Check on the console again. I look into it, let's see what deleting the clusters. Okay. It's gone orange. Yeah. Let's check progress. Okay. Because there's two parts to the master node sits with on the Google side, but on network we don't have even access to that, and the nodes here are on our network in this particular project. It depends, but you can always go back and do the lab. I think you will have 3 attempts on each lab that you can do. Is the timer run out? Is that what you're saying? Yeah, I think it's going to give you 100% anyway, because the process is deleting that anyway. So let's see. So mine is done. Okay. No, it will do it before hopefully the lab finishes. So shouldn't take that long. So I can do, mine is finished. I can do end lab here. Awesome. Submit. 5-star. They deserve it. And if I go back here, what you will find that you've done this lab, the second lab, and the Kubernetes lab. Okay. So what you will have to do, we only have 5 minutes left. On your own, obviously, you're going to have this access for another month. The labs that you need to do is the load balancers and the Cloud Shell and G-Cloud, which we talked about, probably something that is new. It's going to be load balancers. And then they ask you to do a challenge. So the challenge lab, you can see all the other stuff here, they give you the steps. So the challenge lab, they bring all the knowledge that we learned in the other labs, and they give you a scenario, and they will ask you to do some of the tasks that they've done, but they don't give you the steps. So for example, here they're asking you, let's see, create all the resources in default region or zone unless otherwise created. So your challenge is to create a VM instance with this name, with this specification, use the default image, which is Debian Linux, create a Kubernetes service cluster. Again, they give you which zone, the image that you're going to be using, the port that you need to be exposing, and the load balancer. This is what we're going to be doing in that lab. So again, you're going to use the same steps here. And when you finish, we get what you call the skill badge. Skill badge is another one that you could showcase on your social media account, but you have the skills now to use these steps that basically is going to add value to your profile, that you've got those skills in Google Cloud. All right, I think that's all I've got for you today. If you have any questions, obviously you have some more labs to do, got 1 month to do that, so you've got access to that, to other skill badges if you need to. But other than that, well done, everyone. It's been a great session. Thank you for having me. If there is any questions, reach out to the team, reach out to me directly. The team, they're gonna check, share my details with you. I'm happy to answer any questions or any misconceptions that you have, clarifications that you need. We'd be very, very happy to get back to you about those. And hopefully we're gonna do future sessions as well in the future. Happy to accommodate as well. Thank you so much. And thank you for having the time on a Sunday, your weekend time to learn more. I really appreciate it as well. Have a good rest of the day, and inshallah see you in other sessions in the future. Thank you.
Thank you so much, Dr. Nabil. We're very happy to have you here today.
Well,
This was very important. Thank you, everyone. Have a good day ahead.